The night sky stretches endlessly above us, a silent witness to countless cosmic dramas that have shaped everything we know. But among those distant stars and swirling galaxies lie events so profound, they've rewritten the very laws of physics and will dictate what comes next for humanity. Today, we're uncovering 22 of the most extraordinary moments in the universe's history, from cataclysmic explosions that forged the elements in our bodies to mysterious voids where space itself breaks down. These aren't just distant curiosities, they're the reason Earth exists, the hidden forces guiding our future, and perhaps the answer to whether we're alone in this vast expanse. Strap in, this journey will bend your perception of time, space, and our place in the cosmos. 13.8 billion years ago, reality as we know it didn't exist. No stars, no planets, not even empty space. Instead, a single point of infinite density and heat contained all the energy of the cosmos. Then, in a fraction of a second, everything changed. The Big Bang wasn't an explosion into space, it created space, unfurling the fabric of the universe faster than light itself could travel. What's astonishing isn't just the scale of this event, but how much we've pieced together from its aftermath. That faint static on old TV screens, part of it comes from cosmic microwave background radiation, the cooled remnant of that primordial fireball still detectable after all this time. And the very elements in your body, they were forged in the extreme conditions of those first moments, when the universe was a seething plasma of quarks and gluons. But here's where it gets even stranger. The Big Bang doesn't explain why it happened, only how. Was there a before? Some theories suggest our universe might be one bubble in an endless multiverse foam, while others propose cyclical cosmos models where collapse and rebirth repeat eternally. One thing's certain, without this unimaginable beginning, galaxies wouldn't spin, stars wouldn't shine, and life as we know it would never have had a chance to emerge. Even now, the universe expands faster the farther we look, carrying galaxies away like leaves on a cosmic river. The Big Bang didn't just happen once, it's still happening, stretching the very dimensions of reality with every passing second. For nearly 200 million years after the Big Bang, the universe remained a cold, silent expanse, no twinkling lights, no blazing suns, just an endless sea of featureless gas. Then something extraordinary happened. In scattered pockets across the cosmos, gravity began pulling together the simplest elements, hydrogen and helium, squeezing them tighter and tighter until the pressure became unbearable. And with a brilliant flash, the first stars roared to life, tearing through the darkness like cosmic beacons. These weren't anything like the stars we see today. Imagine furnaces hundreds of times more massive than our sun, burning at temperatures so extreme they could only last a few million years before self-destructing in colossal explosions. But their brief, violent existence changed everything. Deep in their cores, nuclear fusion forged entirely new elements, carbon, nitrogen, oxygen, elements that had never existed before. When these early giants finally collapsed, their supernova scattered these precious materials across the cosmos, seeding future generations of stars, planets, and ultimately life itself. Every breath you take contains oxygen forged in those ancient stellar furnaces. The calcium in your bones, the iron in your blood, they were all forged in the hearts of stars that blazed and died before Earth even existed. Yet mysteries remain. We've never directly observed one of these first-generation stars, nicknamed population Roman 3 stars, though astronomers scour the farthest reaches of the observable universe for clues. Some theories suggest they might have formed differently than modern stars, possibly in vast clusters that shaped entire galaxies. What we do know is this: without their cataclysmic births and deaths, the universe would still be a barren void of simple gases. They were the alchemists of the cosmos, turning simplicity into complexity, darkness into light, and setting the stage for everything that followed. For billions of years, Earth's oceans simmered beneath a sky choked with methane and carbon dioxide, a world where life clung to existence in the absence of breathable air. Then a quiet revolution began. Tiny cyanobacteria drifting through ancient seas started harnessing sunlight to produce energy in a way never seen before. Their waste product, oxygen, what began as a slow trickle soon became a deluge, transforming our planet's atmosphere in an upheaval so drastic, scientists call it the Great Oxygen Catastrophe. At first, oxygen was poison. To the anaerobic microbes dominating early Earth, this new gas was deadly, triggering one of the first mass extinctions in history. Yet from this destruction emerged an opportunity. Oxygen's reactivity made it the perfect fuel for more complex biochemical reactions, supercharging evolution like nothing before it. Suddenly, cells could generate nearly 20 times more energy than their anaerobic counterparts. This energy surplus became the foundation for everything from twitching muscles to thinking brains. The echoes of this event are everywhere. The rust-colored bands in ancient rock layers, their iron oxide's chemical scars from when Earth's oceans finally stopped absorbing oxygen and the gas flooded the air. Even today, every lungful you take connects you to that primordial revolution. But the true wonder lies in the paradox. A lethal pollutant became the spark for complexity. Without this upheaval, life might have remained microscopic forever, trapped in an eternal twilight of simplicity. Yet the story isn't just about Earth. It's a blueprint for how cosmic chaos breeds opportunity. Across the universe, catastrophes colliding galaxies, dying stars, even atmospheric revolutions aren't just endings. They're catalysts clearing space for something new to rise. The cyanobacteria couldn't have imagined their waste would one day fuel civilizations. It begs the question, what seemingly destructive forces today might be laying groundwork for wonders we can't yet conceive? Picture this, a world without moonlight, no guiding tides to stir the oceans, no steady rhythm of seasons, just a young Earth spinning wildly on its axis with days barely 6 hours long. Then catastrophe struck. A rogue planet, roughly the size of Mars, now called Theia, slammed into our infant world with unimaginable force. The impact was so violent, it vaporized rock, melted continents, and hurled a swirling storm of debris into orbit. Yet from this cosmic wreckage emerged something extraordinary, our moon. This wasn't just another crater-forming collision. Theia's strike fundamentally reshaped Earth's destiny. As ejected debris coalesced into the moon over millennia, its gravitational pull became Earth's silent guardian. The moon's steady tug slowed our planet's frenetic spin, stretching days to 24 hours, a rhythm that later proved ideal for life's delicate chemistry. Even more crucially, it stabilized Earth's axial tilt, preventing the wild climate swings that leave planets like Mars tumbling between ice ages and infernos. Without that stability, complex organisms might never have gained a foothold. But the moon's influence runs deeper than tides and seasons. Some scientists argue its gravitational forces churned Earth's molten core, amplifying the magnetic field that shields us from deadly solar radiation. Others speculate that the impact itself delivered water-rich minerals, seeding our oceans. What's undeniable is how rare such an event truly is. Of all the rocky planets in our solar system, none have a moon like ours, a colossal partner forged from destruction, yet vital for creation. This cosmic accident echoes a profound truth. Chaos and order aren't opposites, they're partners. The same violence that nearly obliterated Earth set the stage for life's grand symphony. And when we gaze at the moon's scarred surface, we're not just seeing a lifeless rock. We're looking at a relic of the catastrophe that made our existence possible. Earth had barely cooled from its molten adolescence when the solar system turned against it. Between 4 and 3.8 billion years ago, a relentless storm of asteroids and comets rained down on the inner planets, an event so violent, scientists call it the Late Heavy Bombardment. Imagine entire mountain ranges of rock and ice screaming through space, slamming into young worlds with enough force to vaporize oceans and melt continents. Yet hidden in this cosmic onslaught was an unlikely gift, the raw materials for life. The evidence is written in the moon's battered face, those sprawling gray plains we see from Earth. Their ancient lava flows from impacts so massive they cracked the lunar crust. Unlike Earth, where wind and water erase the past, the moon preserves every scar, a perfect record of this chaotic chapter. But here's the twist. While these collisions brought destruction, they also carried riches. Icy comets likely delivered much of Earth's water, while carbon-rich asteroids may have seeded our planet with amino acids, the building blocks of proteins essential for life. Some scientists argue this bombardment wasn't random. Jupiter's shifting gravity could have hurled debris inward like a cosmic pinball machine gone rogue. Others speculate that a wandering planet now lost to time disrupted the asteroid belt. Whatever the cause, the timing was eerily perfect. The impacts tapered off just as Earth's crust stabilized, creating a window for life to emerge in newly formed oceans. Modern missions aim to solve the riddle. By analyzing lunar craters untouched by erosion, we might uncover what these ancient projectiles carried. Could life's ingredients really have hitchhiked on asteroids, or was Earth already brewing them in hydrothermal vents? One thing's certain, the same violence that once threatened to sterilize our planet might have handed us the keys to existence, proof that in the universe, catastrophe and creation often share the same moment. For billions of years, life on Earth moved at a glacial pace, single-celled organisms drifting through ancient seas, their forms barely changing across eons. Then, around 540 million years ago, something extraordinary shattered this slow march. In what scientists call the Cambrian Explosion, the evolutionary rulebook was torn apart. Within just 20 million years, a mere heartbeat in geological time, the oceans teemed with creatures sporting eyes, claws, armored shells, and even the first backbones. It was as if life itself had suddenly discovered imagination. What triggered this creative frenzy? One key lies in the chemistry of the planet. Oxygen levels had finally reached near modern concentrations, fueling energy-hungry multicellular bodies. But atmosphere alone doesn't explain the dizzying array of body plans that emerged, some so bizarre they seem alien. The predatory Anomalocaris, with its circular mouth lined with serrated plates, or Hallucigenia, a spiny worm-like creature whose legs and spines left paleontologists baffled for decades. Genetic clues hint at another piece of the puzzle. Around this time, a toolkit of developmental genes known as Hox genes evolved, acting like biological switches that could sculpt bodies segment by segment. Suddenly, nature had a recipe book for endless variations. Some researchers speculate that predator-prey arms races accelerated innovation as survival demanded ever more sophisticated adaptations. Yet the Cambrian explosion remains one of biology's greatest enigmas. Why did it happen then, and why hasn't such rampant innovation occurred since? Perhaps it was a perfect storm, oxygen, genetics, and ecological opportunity colliding. Or maybe, as some radical theories suggest, a spike in cosmic radiation triggered mutations. Whatever the cause, the message is clear. When the universe flips a switch, life doesn't just adapt, it reinvents itself. Today, every vertebrate on Earth, from hummingbirds to humans, traces its lineage back to one of those first bold experiments. The Cambrian didn't just diversify life, it proved that evolution, given the right conditions, can operate at breakneck speed. And that raises a tantalizing thought. If it happened here, could such explosive creativity be rewriting the story of life elsewhere in the cosmos right now? For 200 million years after the Cambrian explosion, life on Earth flourished in countless forms until the planet itself turned against them. 252 million years ago, disaster struck with a brutality unmatched before or since. The Permian-Triassic Extinction, known as the Great Dying, didn't just thin the ranks of species, it erased 96% of all marine life and 70% of terrestrial vertebrates. The triggers read like a checklist for doomsday. Apocalyptic volcanic eruptions in Siberia spewed enough lava to bury continents. Toxic gases poisoned the air, and runaway global warming boiled the oceans until they turned acidic. What made this catastrophe unique wasn't just its scale, but its speed. Geological records show entire ecosystems collapsing in less than 60,000 years, a blink in Earth's timeline. Deep-sea sediments reveal layers of fossilized bacteria that thrived in oxygen-starved waters, painting a picture of oceans suffocating under their own toxicity. Yet hidden in this devastation was a paradox. The same volcanic activity that choked the planet also broke the supercontinent Pangaea apart, creating new coastlines and habitats ripe for recolonization. From this near-total reset, evolution took a radical turn. The few survivors, small, adaptable creatures like Lystrosaurus, a pig-sized reptile, inherited a nearly empty world. With competition erased, these generalists diversified explosively, setting the stage for dinosaurs to dominate just 10 million years later. Their rise underscores a cosmic truth: extinction isn't just an end, it's a forced innovation. The meek didn't inherit the Earth, the versatile did. Modern parallels are eerie. Today's ocean acidification and carbon spikes mirror conditions from the Great Dying, offering a sobering case study. Yet Earth's story argues against despair. Life didn't merely recover after this catastrophe, it reinvented itself, proving that even in the universe's darkest hours, adaptation writes the next chapter. The real question isn't whether life survives, but what emerges from the ashes. The reign of dinosaurs stretched over 160 million years until a single day rewrote Earth's destiny. 66 million years ago, a 6-mile-wide asteroid, traveling faster than a rifle bullet, punched through the atmosphere near what's now Mexico's Yucatan Peninsula. In less than a second, it released energy equivalent to billions of atomic bombs, carving a crater 110 miles wide and 12 miles deep. But the initial impact was just the opening act of a planetary nightmare. Within hours, debris raining back through the atmosphere turned the sky into a glowing oven, igniting wildfires across continents. Tsunamis taller than skyscrapers radiated from the impact zone, scouring coastlines thousands of miles away. Then came the long winter. Sunlight vanished for years beneath a shroud of ash and sulfur, collapsing food chains worldwide. Dinosaurs, perfectly adapted to their lush world, found no refuge from this abrupt climate shift. Yet tucked in burrows and hidden in waterways, small, adaptable mammals weathered the storm. Creatures no larger than rats, but with a crucial edge: they could eat almost anything. Modern drilling into the Chicxulub crater has revealed chilling details. Layers of sediment show a sudden spike in iridium, a metal rare on Earth but common in asteroids, smoking gun evidence of cosmic intervention. But the deeper lesson lies in the aftermath. With giant predators gone, mammals exploded into ecological niches once forbidden to them. Primates, bats, even whales all trace their lineage to survivors of that catastrophe. This event forces a humbling perspective. Humanity's existence hinges on a fluke, a random collision that erased one world to make space for another. It's a reminder that evolution isn't just about gradual change, but about moments when the universe itself hits the reset button. And that raises a chilling question. Somewhere out there, could another rock be hurtling toward us, carrying the next chapter of Earth's story? The African savanna wasn't always a cradle of life, it was a proving ground. 200,000 years ago, while other hominids like Neanderthals dominated Eurasia with brute strength, a new contender emerged in the south, Homo sapiens. We didn't start as the mightiest or the fastest. Our advantage was subtler, woven into the very fabric of our minds. Fire became our first great equalizer. Unlike other animals that feared flames, we harnessed them, cooking food to unlock more nutrients, warding off predators, and gathering around hearths that doubled as storytelling circles. Tools evolved from crude stones to precision blades, each generation refining techniques and passing knowledge forward. But the real game changer was language. Where other species communicated basic warnings, we spun narratives sharing not just what happened, but why and what might come next. This let us plan, cooperate, and innovate at a pace no other creature could match. Yet luck played its part. Climate swings pushed our ancestors to adapt or perish, while genetic mutations gifted us with brains capable of abstract thought. Some scientists argue that a cognitive great leap around 70,000 years ago, perhaps sparked by symbolic art and complex tools, catapulted us ahead of rival hominids. Others suggest our edge was social, the ability to form larger, more trusting groups. The cosmic irony is profound. In a universe governed by physics, consciousness somehow emerged as a force that reshapes planets. Did the laws of nature favor minds like ours, or is our dominance just one roll of the dice in a multiverse where other intelligences rule? Either way, our story is far from over. As we reach for Mars and decode quantum realms, we're still answering the same ancient question. What happens when a species born under African skies tries to conquer the stars? Perhaps the universe has been waiting for something like us all along, not as its final act, but as a new chapter in an epic that began with stardust. For millennia, humans gazed at the night sky with naked eyes, interpreting celestial motions through myth and dogma. Then, in 1609, a curious instrument originally crafted for spotting distant ships found its way into the hands of an Italian mathematician named Galileo Galilei. With a simple arrangement of lenses, the telescope tore open the curtains of cosmic ignorance, revealing truths more astonishing than anyone had dared to dream. Galileo's first sketches of the moon shattered centuries of belief. Its surface wasn't a perfect celestial sphere as Aristotle claimed, but a rugged world pocked with mountains and valleys, a place, not a symbol. When he turned his telescope toward Jupiter, the discovery was even more revolutionary. 4 moons orbiting another world, proving not everything revolved around Earth. Night after night, evidence mounted against the geocentric model, showing Venus waxing and waning like a miniature moon, behavior impossible if it circled Earth as medieval astronomers insisted. The backlash was swift. Challenging Earth's central place in the cosmos wasn't just science, it was heresy. Yet Galileo's observations ignited a chain reaction. Within decades, telescopes grew sharper, revealing Saturn's rings, the craters of Mars, and eventually, the swirling arms of distant galaxies. What began as a novelty in a Dutch optician's workshop became humanity's most transformative tool. The key to measuring stellar distances, uncovering dark matter, and glimpsing the infancy of the universe itself. This shift wasn't just technical, it was psychological. For the first time, we had proof that the universe obeyed physical laws we could decipher. The telescope didn't merely magnify distant objects, it expanded the very scope of human curiosity. And in that expansion lies a humbling truth. Some of history's greatest leaps begin not with grand theories, but with the courage to point a simple tube at the sky and really look. Modern observatories, from mountaintop mirrors to spaceborne giants like Hubble, are all descendants of Galileo's rudimentary spyglass, yet their purpose remains unchanged: to strip away assumptions and reveal the cosmos as it truly is, not as we wish it to be. Every time we peer deeper, we honor that first, audacious act of looking beyond ourselves. At the dawn of the 20th century, physics stood on a precipice. Newton's orderly universe of absolute time and space had reigned for over 200 years until a soft-spoken patent clerk in Switzerland scribbled down equations that would shatter that comforting illusion. Albert Einstein didn't just tweak our understanding of gravity, he rewrote the rules of reality itself with his theory of relativity. The first clue came from light. Einstein realized that no matter how fast you move, light's speed remains constant, a paradox that demanded a radical solution. If speed couldn't change light's behavior, time itself had to bend. Imagine two identical clocks, one on a rocket hurtling through space, the other on Earth. Relativity dictates the rocket's clock ticks slower, not because it's broken, but because time literally stretches under motion. GPS satellites account for this effect daily. Without relativistic corrections, their navigation data would drift by miles within hours. But the real revolution lay in gravity's true nature. Einstein proposed that massive objects like stars don't just pull on things, they warp the very fabric of spacetime, creating curves that guide planets and light alike. Picture a bowling ball sinking into a trampoline. Marbles rolling nearby spiral inward, not because of some invisible force, but because the surface itself is distorted. This insight predicted black holes decades before we found them, cosmic pits where spacetime bends so severely, not even light can escape. The echoes of Einstein's work are still unfolding. In 2015, scientists detected gravitational waves, ripples in spacetime from colliding black holes over 1 billion light-years away. These vibrations matched his equations to near-perfect precision, proving spacetime isn't just a static stage, but a dynamic, quivering entity. Relativity's legacy isn't just about exotic physics. It's a testament to human curiosity's power to peel back layers of the universe, revealing wonders hidden in plain sight. The cosmos operates not by rigid absolutes, but by fluid relationships, a reminder that sometimes the most profound truths emerge when we dare to question what seems unquestionable. In the swirling dance of galaxies, astronomers uncovered a cosmic mystery that defied every expectation. When scientists first calculated how fast stars should orbit galactic centers based on visible matter alone, the numbers didn't add up. Stars at the edges of spiral galaxies were moving too fast, so fast, in fact, that the galaxies should have flung themselves apart long ago. Yet there they were, spinning gracefully as if held together by invisible hands. The only explanation, something massive and unseen dark matter, must be weaving a gravitational web throughout the universe. What makes this discovery so startling isn't just that we can't see it, it's how much of everything dark matter actually is. Together with its even more elusive counterpart, dark energy, this invisible substance accounts for about 95% of the universe's total mass and energy. The stars, planets, and galaxies we observe, just cosmic frosting on a cake we're still struggling to describe. The hunt for dark matter's true nature has led physicists down some fascinating paths. Some theories suggest it's made of exotic, slow-moving particles that barely interact with normal matter, WIMP, weakly interacting massive particles being one leading candidate. Others propose that we might need to rewrite gravity itself, modifying Einstein's equations to account for the discrepancy. Experiments deep underground in space and inside giant particle colliders continue the search, but so far, dark matter remains tantalizingly out of reach. Yet its fingerprints are everywhere. The way galaxies cluster together, the bending of light around massive objects, even the large-scale structure of the universe, all point to dark matter's invisible scaffolding. Without it, the cosmos as we know it wouldn't exist. This raises a humbling thought. We've mapped entire star systems and decoded the birth of the universe, yet most of reality is still hidden from us. Perhaps that's the lesson dark matter teaches best. Science isn't about having all the answers, it's about chasing the next question, no matter how deep into the unknown it leads. And if the universe is content to keep its biggest secrets just out of reach, that only makes the hunt more thrilling. In the vast cosmic theater, a discovery in the late 1990 sent shockwaves through astronomy, one so unexpected even Einstein had dismissed it as his greatest blunder. Distant supernova, used as cosmic mile markers, revealed something impossible. The universe wasn't just expanding, it was accelerating. Something invisible, dubbed dark energy, was pushing galaxies apart faster with each passing moment. What makes this force so baffling is how it defies gravity's pull. Imagine tossing a ball into the air, only to watch it shoot away faster instead of falling back. That's the reality on a cosmic scale. Measurements suggest dark energy makes up 68% of the universe's total energy, a pervasive presence woven into the fabric of space itself. Some theories propose it's the energy of empty space growing stronger as the universe stretches. Others speculate it might be an entirely new force, one we've yet to name. The stakes couldn't be higher. If acceleration continues unchecked, dark energy could trigger a big rip, a catastrophic end where not just galaxies but atoms themselves are torn apart. Alternatively, its strength might wane, letting gravity claw back everything in a big crunch, reversing the Big Bang. There's even a third option, a slow, cold fade into darkness as stars burn out and space grows too vast for light to bridge. Clues might lie in Einstein's cosmological constant, a term he once added and later abandoned. To balance his equations, was he right all along, just too early? Upcoming telescopes like the Roman Space Telescope aim to measure dark energy's grip with unprecedented precision. Whatever they find will rewrite our cosmic destiny. For now, we're left with a humbling truth. The universe's grand finale isn't written yet. And in that uncertainty lies both terror and wonder, a reminder that we're not just observers of the cosmos, but participants in its unfolding story. The same expansion that threatens to scatter galaxies also bought time for planets, life, and minds to emerge. Dark energy may dictate how it all ends, but for now, it's the reason we're here to ponder it at all. For nearly a century, gravitational waves existed only as scribbles in Einstein's equations, a mathematical prediction so subtle, even he doubted we'd ever detect them. Then on September 14, 2015, humanity's most sensitive instruments caught a whisper from the void. Two black holes, each about 30 times the mass of our Sun, had spiraled into each other over 1.3 billion years ago, warping spacetime so violently the ripples finally reached Earth. The signal lasted just 0.2 of a second, but that fleeting tremor marked the dawn of an entirely new way to explore the cosmos. What makes this discovery revolutionary isn't just the confirmation of Einstein's genius. Gravitational waves carry information no telescope can see. Light gets blocked or scattered. These waves pass through everything, offering an unfiltered soundtrack of cosmic violence. When neutron stars collided in 2017, observatories detected both the spacetime ripples and the resulting gamma-ray burst, a breakthrough called multi-messenger astronomy. For the first time, we didn't just watch the universe, we felt its vibrations. The technology behind this achievement boggles the mind. LIGO detectors measure changes smaller than 1,000th the width of a proton, using lasers traveling down 2.5 mile long vacuum tubes. That's like sensing a hair's breadth shift in the distance to Alpha Centauri. Now, newer observatories like the space-based LISA promise to tune into even lower frequencies, potentially hearing the primordial echoes of the Big Bang itself. Yet the most poetic insight lies in what these waves reveal about spacetime. It's not a rigid stage but a flexible fabric, quivering like a drumhead when massive objects move. Every black hole merger, every neutron-star collision composes a note in this cosmic symphony, and after eons of silence, we've finally learned to listen. The universe isn't just showing us its secrets anymore, it's singing them, and with each new detection, we're deciphering melodies from the darkest, most violent corners of existence. For centuries, black holes existed only in theory, mathematical ghosts hiding in Einstein's equations, their true form left to speculation and science fiction. Then, in April 2019, humanity witnessed the impossible, a photograph of the abyss itself. The Event Horizon Telescope, a planet-sized array of observatories, unveiled the first ever image of a black hole's silhouette, a fiery ring framing a perfect sphere of darkness at the heart of the galaxy M87. What we're seeing isn't the black hole itself by definition. These cosmic traps allow no light to escape. Instead, the glowing halo is radiation from superheated gas spiraling into oblivion, its light bent into a circle by the black hole's immense gravity. The shadow at its center, the point of no return, the event horizon where the laws of physics as we know them cease to function. Yet this image is more than a triumph of engineering. It's a window into extreme physics. General relativity predicted this precise ring shape, and the photo matched Einstein's math with eerie accuracy, but mysteries linger. Some theories suggest black holes might be gateways to other dimensions or even time tunnels, their interiors hosting alternate universes. Others propose that information swallowed by black holes isn't truly lost but encoded on their surfaces, a cosmic hologram. The implications ripple far beyond astronomy. If black holes can warp spacetime so severely that time nearly stops at their edges, what does that mean for our understanding of existence itself? Are we glimpsing the universe's underlying code, written in gravity's most violent language? For now, the answers remain as elusive as the darkness at the heart of M87. But one thing's certain, this single image didn't just capture a black hole, it ignited a new era of cosmic exploration, proving that even the universe's most secretive monsters can't hide forever when human curiosity comes knocking. And if history's any guide, the closer we look, the stranger reality becomes. The universe teems with billions of planets, warm, wet, and bathed in starlight just like Earth. Yet amid this cosmic abundance, one haunting question persists. Is life truly out there, or are we an impossible fluke? The search for extraterrestrial life has evolved from ancient skyward myths to a cutting-edge scientific pursuit, with probes scouring Martian soil and missions planned to crack open the icy shells of distant moon. Mars, once thought crisscrossed by canals built by intelligent beings, has revealed a subtler truth. NASA rovers have uncovered dried riverbeds, mineral traces of ancient lakes, and even organic molecules, all hints that the red planet may have once cradled life. The Perseverance rover now collects samples that could, for the first time, contain fossilized microbes, waiting for a future mission to ferry them back to Earth for analysis. But Mars isn't the only contender. Far beyond the asteroid belt, Jupiter's moon Europa hides a secret beneath its frozen crust, a global ocean kept liquid by tidal forces with more water than all of Earth's seas combined. Plumes of water vapor erupting from its surface suggest hydrothermal vents and environments strikingly similar to those where life thrives in our own ocean depths. Upcoming missions like Europa Clipper aim to taste these plumes, hunting for the chemical signatures of biology. The strategy is twofold. First, follow the water. Where there's liquid, there's hope. Second, listen for signals. Projects like SETI scan the stars for artificial radio waves, while new telescopes analyze exoplanet atmospheres for gases like oxygen or methane, potential fingerprints of living worlds. Yet the deeper we look, the more profound the implications become. If we find even a single microbe beyond Earth, it would mean life isn't rare but inevitable, a cosmic constant. Conversely, silence would suggest our pale blue dot might be more precious than we ever imagined. Either way, the search itself is reshaping humanity's place in the universe. We may not have answers yet, but every experiment, every mission brings us closer to solving one of existence's greatest riddles. And when, or if we finally detect that first faint whisper of alien life, it won't just change science. It will redefine what it means to be alive in this vast, mysterious cosmos. In the summer of 1977, as disco music topped the charts and personal computers were still a novelty, NASA launched two modest spacecraft on what would become humanity's most far-reaching mission. Voyager 1 and 2 weren't just built to explore planets. They were designed to outlive us. Now, over 4 decades later, these twin pioneers have achieved the unimaginable. Voyager 1 slipped past the Sun's protective bubble in 2012, becoming the first human-made object to sail into the interstellar void. What's remarkable isn't just the distance they've covered, over 14 billion miles, but the cultural time capsule they carry. Each probe holds a golden record, a 12-inch gold-plated copper disc packed with sounds and images chosen to tell Earth's story. Whale songs, crashing waves, greetings in 55 languages, even the brainwaves of a woman falling in love, all etched into grooves meant to survive 1 billion years in the vacuum. The records are cosmic postcards addressed not just to potential aliens but to the future itself. Yet the real magic lies in their longevity. Long after skyscrapers crumble and continents shift, the Voyagers will drift among the stars, their nuclear power sources slowly fading. In 5 billion years, as our dying sun swells into a red giant, these silent travelers may be the last intact artifacts of human civilization, proof that a species once looked up and dared to reach beyond its cradle. Their journey raises profound questions. Could some distant intelligence one day decode our messages, or will the records remain untouched, floating through the galaxy's silent vastness? Either way, the Voyagers have already accomplished something extraordinary. They've taken fragments of our world and set them adrift in the cosmic ocean, turning humanity's whispers into eternal echoes. For now, their faint signals, weaker than a smartphone's transmission, still reach Earth, carrying data from the edge of the unknown. Soon, their voices will fall silent, but their voyage will continue. Long after we're gone, they'll bear witness to the fact that we were here, we wandered, and we reached for the stars. For generations, space exploration was the exclusive domain of nations. A high-stakes game played by superpowers with bottomless budgets and political agendas. Then, in the early 2000s, something remarkable shifted. A group of entrepreneurs looked at the stars and saw not just frontiers but real estate. Companies like SpaceX, Blue Origin, and Virgin Galactic began rewriting the rules, proving that rockets could be reusable, costs could plummet, and space might one day be as accessible as air travel. The numbers tell the story. Where NASA once spent $1.5 billion per space shuttle launch, SpaceX's Falcon 9 now delivers payloads to orbit for a fraction of that and lands its boosters upright on drone ships ready to fly again. This isn't just about efficiency, it's a fundamental reimagining of what's possible. Private firms have already ferried astronauts to the International Space Station, deployed thousands of internet satellites, and tested prototypes for Martian rockets. The dream of a self-sustaining city on Mars, once confined to sci-fi paperbacks, now has blueprints and billion-dollar backers, but the real revolution lies in who gets to go. Space tourism, once a punchline, has become a burgeoning industry. Ordinary civilians, not just astronauts, have circled Earth, floated in zero gravity, and gazed down at our fragile blue marble from the edge of space. Lunar hotels and orbital cinemas may sound fantastical, but companies are already drafting the permits. Critics argue this era prioritizes profit over science, yet the data paints a different picture. Private ventures have accelerated innovation, from 3D printed rocket engines to AI-guided landings. And when SpaceX's Starship finally lifts off for Mars, it won't carry just flags and footprints. It could carry the seeds of an entire branch of civilization. The message is clear: the age of space monopolies is over. Whether it's a researcher hitching a ride on a private lunar lander or a couple honeymooning in orbit, the cosmos is opening its doors. For the first time in history, the stars aren't just destinations, they're neighborhoods. And humanity, we're not just visiting, we're moving in. For decades, astronomers studied the cosmos through a keyhole limited by technology that could only glimpse fragments of the universe's grand story. Then, on Christmas Day 2021, humanity flung open a window to the past. The James Webb Space Telescope, with its golden honeycomb mirrors and infrared eyes, launched on a mission to see further and clearer than any telescope before it. Within weeks, it began rewriting cosmic history. The magic of Webb lies in its ability to catch whispers of light that have traveled for billions of years. Unlike Hubble, which primarily sees visible light, Webb detects infrared, the faint warmth lingering from the universe's earliest epochs. Its first deep-field image, a pinprick of sky no larger than a grain of sand held at arm's length, revealed thousands of galaxies, some dating back to within 200 million years of the Big Bang. These weren't just ancient relics, they were cosmic toddlers, more massive and structured than anyone predicted, forcing scientists to reconsider how galaxies form. But the surprises didn't stop there. Webb turned its gaze to exoplanets, dissecting their atmospheres with spectrometer precision. In the haze of a distant world named K2-18b, it detected potential signs of dimethyl sulfide, a compound on Earth produced only by life. While no smoking gun for aliens, it marked the first time we'd sniffed the air of a habitable zone planet. Now, the telescope is poised to tackle even bigger mysteries. How did the first stars ignite? What dark forces shaped the universe's web-like structure? And just how common or rare are Earth-like worlds? Every new image isn't just a photo. It's a time machine, peeling back layers of cosmic history we've only ever theorized about. Webb's greatest revelation might be how little we truly know. Each discovery raises fresh questions, proving the universe is far stranger, more varied, and more wondrous than we dared imagine. And as the telescope peers ever deeper, one truth becomes clear: we're not just observers of the cosmos, we're its students, humbled by the vastness still left to explore. The blue skies over Chelyabinsk, Russia, were shattered without warning on a frigid February morning in 2013. What began as a blinding streak of light brighter than the sun ended in a shockwave that blew out windows, injured 1,500 people, and served as humanity's starkest reminder in decades: we're not alone in this cosmic neighborhood. The Chelyabinsk Meteor, a 65-foot-wide space rock exploding with 30 times the force of the Hiroshima bomb, wasn't some ancient catastrophe. It happened now, in the age of smartphones and satellites, proving that asteroid impacts aren't just relics from the dinosaurs' demise, they're an ever-present risk. But here's the twist: for the first time in Earth's history, we're not just potential victims of these cosmic bullets. We're becoming sharpshooters. NASA, a DART mission in 2022, marked a turning point. A spacecraft the size of a vending machine deliberately crashed into a harmless asteroid named Dimorphos, altering its orbit. This wasn't just a scientific curiosity, it was humanity's first test of planetary defense, and it worked. By nudging Dimorphos, we proved that with enough warning, we could deflect a real threat away from Earth. The challenge now shifts from theory to vigilance. The Chelyabinsk Meteor arrived unseen because it came from the sun's glare, a blind spot for telescopes. Today, projects like the Vera Rubin Observatory scan the skies nightly, cataloging thousands of near-Earth objects, while space-based proposals aim to patrol those treacherous sunward approaches. Early detection is everything an asteroid spotted decades in advance could be gently guided off course, while one discovered too late might leave us with only evacuation plans. What's both humbling and empowering is the scale of the stakes. The same cosmic collisions that once delivered Earth's water, and perhaps life's building blocks, could also undo everything we've built. But unlike the dinosaurs, we can see the threat coming, and for the first time we're learning how to fight back. The universe may still throw rocks, but we're no longer just standing in the line of fire. We're stepping aside, or better yet, catching them midair. Somewhere in the vast darkness between galaxies, a flash of energy brighter than 500 million suns erupts and vanishes in less time than it takes to blink. These are fast radio bursts, some of the universe's most puzzling signals. First detected in 2007, these millisecond-long blasts of radio waves arrive from billions of light-years away, carrying more energy than our sun emits in 80 years. Yet despite their power, their origins remain one of astronomy's greatest whodunits. At first, astronomers wondered if these bursts were celestial glitches, cosmic static from colliding neutron stars, or black holes spaghettifying nearby stars. Then came the repeating bursts. Unlike one-off events, these signals pulsed multiple times from the same patch of sky, ruling out cataclysmic collisions. Some theories point to highly magnetized neutron stars called magnetars, whose crust-quaking starquakes might unleash these brilliant flares. Others suggest phenomena we've yet to imagine, like cosmic strings or even primordial black holes evaporating. But the intrigue doesn't stop there. When scientists traced one burst to a relatively nearby galaxy, its fingerprint contained a bizarre clue: the signal was twisted. This polarization suggests it passed through an intense magnetic field, perhaps near a supermassive black hole. Another burst carried a pattern eerily reminiscent of a heartbeat, sparking short-lived speculation about artificial origins. While extraterrestrial beacons are astronomically improbable, the burst's precision keeps the question lingering at the edges of science. The race to solve this mystery is accelerating. New telescopes like Canada's CHIME scan the sky daily, cataloging hundreds of bursts and mapping their cosmic addresses. Each detection peels back another layer, revealing clues about the otherwise invisible material these waves traverse across intergalactic space. What's certain is this: fast radio bursts aren't just cosmic oddities, they're messengers. Every millisecond flash carries encrypted details about the universe's structure, the distribution of matter, and the extreme physics governing the cosmos' most violent neighborhoods. And as we decode them, we're not just chasing answers, we're learning how to listen to the universe's most fleeting, furious whispers. Picture the last star in the universe, its faint glow sputtering out like a dying ember, leaving behind a sea of black holes and frozen cinders. This isn't science fiction. It's the inevitable finale dictated by one of physics' most unshakable laws: entropy. Over trillions upon trillions of years, every sun will exhaust its fuel, every galaxy will disperse into darkness, and the cosmos will settle into a state of perfect, icy equilibrium. No more light, no more heat, just an endless expanse where even time loses meaning. But how do we know this fate awaits us? The clues lie in something as mundane as a cup of coffee. Just as steam dissipates into the air and warmth fades into the room, the universe is doing the same thing on a cosmic scale. Energy spreads thin, matter drifts apart, and disorder grows until nothing remains to spark change. Even black holes, those seemingly indestructible monsters, aren't immune. Given enough time, think numbers with over 100 zeros, they'll evaporate into faint bursts of radiation, leaving behind a void so empty not even atoms stir. Yet this bleak portrait holds a strange glimmer of hope. Some theorists suggest advanced civilizations could outwit entropy by harvesting energy from evaporating black holes or creating pocket universes. Others propose that consciousness itself might transcend physical decay, migrating to artificial substrates that endure long after stars vanish. These ideas teeter on the edge of science and philosophy, but they reveal something profound. Intelligence might be the universe's wild card, a way to cheat its own grim rules. The irony is poetic. Billions of years from now, when the last star winks out, the cosmos could become a library of frozen knowledge. Every book written, every song composed, every discovery made preserved in perfect stasis. Our descendants, or whatever they evolve into, might face a choice: surrender to the cold or rewrite the story. Either way, the heat death isn't just an ending, it's the ultimate test of ingenuity. And if life has proven anything, it's that where there's a will to survive, even the laws of physics might not be final. From the searing birth of the cosmos to the silent drift of galaxies into darkness, these 22 chapters have woven an astonishing tapestry, one where cataclysms birth life, where invisible forces sculpt reality, and where curiosity alone bridges the gulf between stardust and sentience. Look up tonight, and you're not just seeing points of light. You're witnessing echoes of supernova that forged your atoms, the gravitational whispers of black holes older than time, and perhaps, just perhaps, the faint glow of worlds where other minds gaze back at the same stars. Our story is written in the language of cosmic violence and delicate chance. A planet struck by chaos yet cradled by moon and magnetism. A species that turned sunlight into art and gravity into a roadmap. Now the pen passes to us. Will we become the architects of solar systems, the healers of biospheres, or just a brief flicker in the universe's cold expanse? The answer lies in the questions we dare to ask next and the frontiers we choose to chase. So tell us, when you picture humanity's future among the stars, what do you see? A symphony of thriving colonies, the quiet hum of probes carrying our legacy beyond the Milky Way. Or something stranger still? Drop your visions in the comments, and if you've loved this voyage through space and time, hit subscribe. The universe has infinite stories left to tell, and we're just getting started.